All right, let's dive into a really fascinating little mystery that's probably hiding right inside your algebra textbook. Today, we're going on a hunt for something I like to call mathematical imposters. And to get us started, I've got a question for you.
Kind of weird to think about, right? I mean, we trust algebra, we follow the steps, and we expect them to lead us to the right answer. But what if I told you that sometimes the process itself can spit out an answer that looks perfectly logical, but is actually completely wrong?
So, meet our culprit, the extraneous solution. The best way to think of it is as a ghost solution. It's an answer that pops up while you're doing your work, it seems totally legit, but when you go back to the beginning, it just doesn't fit. It's an imposter. And our job today is to learn how to spot these ghosts and, well, kick them out.
Now, you should know these imposters don't just show up out of nowhere. They're actually created by a very specific mathematical action, a trap, that's super easy to fall into if you're not looking for it. And there it is, the one single action that lets these ghost solutions sneak in, squaring both sides of an equation. It seems so harmless, right? But believe me, this is the exact moment the mathematical crime is committed.
And here's why it's such a problem. Squaring something, well, it isn't reversible. Just look at this. -5 squared is 25. And +5 squared, also 25. Once you square it, that original sign, that super important piece of info, it's just gone. Poofs. And that ambiguity is exactly what allows these fake solutions to get in.
Okay, so we know who the culprit is, and we know how they get in. So the big question is, how do we catch them? Well, the good news is there's a super reliable strategy. Think of it like a detective's toolkit that is going to work every single time.
Here's your two-step interrogation process. It's really simple. First, the quick check. If you ever get an isolated square root that's equal to a negative number, just stop right there. Game over. There's no solution. Second, the full check. You have to, and I mean always, plug your final answers back into the original equation. If it doesn't work, you found your imposter.
All right, enough with the theory. Let's get our hands dirty. We're going to head to the crime scenes. We've got 3 different case files here, and we're going to put our new detection strategy to the test.
Our first case is, well, it's pretty straightforward. We're being asked to solve the square root of x equals -3. This is where those brand new detective skills of yours should be going off like an alarm bell. And boom, this is a perfect time for our quick check. That little radical symbol, the principal square root, by definition, can't be negative. We don't even have to touch our pencils to know there's no solution here. Case closed. Easy, right? Okay, on to our next case. This one's a little more clever. The imposter isn't just going to stand up and wave at us. The algebra here is actually going to give us 2 potential suspects, and we're going to have to do a little investigating to find the truth.
So we just follow the procedure. We square both sides to get rid of the root. We move everything over to one side to get a nice quadratic, and then we factor it. The algebra tells us we have 2 suspects, x equals 4 and x equals -1. But are they both legit? It's interrogation time. This is where we do our full check. We take 4 and plug it back into the original equation. And would you look at that? It works perfectly. 3 equals 3. That's a valid solution. But now look what happens when we check -1. We get 2 equals -2. That is absolutely false. We've unmasked our imposter. X equals -1 is an extraneous solution.
For our final case file, the process is exactly the same, but it really drives home just how critical that final check really is. Just like before, the algebra is going to give us 2 possible answers, and we need to figure out which one, if any, is telling the truth.
So we do the math, and we get 2 candidates, x equals 3 and x equals -1. Let's run our check. When we plug in 3, it works out perfectly. But when we check x equals -1, we get the false statement 1 equals -1. And there it is again, another extraneous imposter caught red-handed.
Okay, so we've seen how to catch these guys. Now let's wrap this all up by talking about the key rules you need to remember so you never get fooled by these ghost solutions ever again. Think of this as your new detective's code. Rule number 1, always check your solutions. No excuses. Rule number 2, and listen up, because this is the most important one, you have to return to the scene of the crime. That means you must check your answer in the original equation with the square root. Checking it in the squared version is pointless. That's the compromised equation where the imposter was born in the first place.
So at this point, you might be thinking, okay, this is a neat little math trick, but does this actually matter for anything? And the answer is, oh yeah, it absolutely does. This is not just some random exercise for your algebra class.
Think about it. In fields like physics and engineering, the equations they use to model the real world can give multiple answers. And some of those answers can be extraneous solutions that represent things that are physically impossible, like negative time or something traveling a negative distance. So engineers have to be these mathematical detectives to know which solutions describe reality and which ones are just ghosts. And really, that's the main takeaway here. Your algebra, all those steps you follow, it's just a tool for generating potential candidates for an answer. But you are the final judge. You're the detective who has to interrogate those candidates to find the one true solution. So, you've totally mastered the art of unmasking imposters in equations with square roots. But let me tell you, these ghosts don't just haunt radical equations. Which leaves us with one last question to think about. Where else in the world of mathematics do you think you're going to need to keep these detective skills sharp? Because the hunt is really just getting started.